Welcome to the AI Research Roundup. I'm Alex. Today, we're looking at a paper from the Hugging Face trending list, published on February 13th, 2026, just about 3 days ago. It introduces a new medical foundation model that outperforms leading closed-source systems like GPT 5.2 thinking, achieving scores of about 77% on the MMMU-Val Med benchmark and 96% on MedXIAOHE. The paper is titled MedXIAOHE, a comprehensive recipe for building medical MLLMs. And as we'll see later, the comprehensive training recipe they propose has significant implications for how we handle complex clinical reasoning. So, Figure 1 backs up these claims with a direct head-to-head comparison against state-of-the-art models. On the left, the overall average across more than 30 benchmarks places MedXIAOHE at the top, with a score of nearly 69, clearly surpassing both Gemini 3.0 Pro and GPT 5.2 thinking. Then, the 6 panels on the right break this down by capability. We see the model maintaining a lead in diverse areas like visual diagnosis and medical text, which suggests it is robust enough for real-world tasks. Well, to understand how it achieves these results, Figure 2 breaks down the MedXIAOHE architecture. Starting at the bottom, notice that the model accepts diverse medical inputs, from X-rays and CT scans to high-resolution ultrasound images. Because these vary wildly in size and aspect ratio, a multimodal native resolution transform processes them intact, so fine details are preserved. Then, the middle section shows how these visual features are encoded by the CVIT backbone and projected into the language space. Finally, at the top, the model interleaves these visual tokens with text, allowing it to reason through patient records and external knowledge bases in a unified dialogue. Alright, precise performance metrics appear in Table 1, comparing MedXIAOHE against GPT 5.2 thinking and Gemini 3.0 Pro. In the visual diagnosis section at the top, the model achieves about 88% on the MMMU-Val Med benchmark. Moving down to medical text, it reaches nearly 98% on the MedXIAOHE, which is a key standard for clinical knowledge. Even though Gemini 3.0 Pro remains strong in isolated imaging tasks, MedXIAOHE sweeps the board with the highest scores in most categories. So, to achieve such broad coverage, Figure 4 illustrates the medical entity tree, or MET, which organizes the training data. At the top, we see high-level categories like disease and syndrome, medical techniques, and pathogens. These branch down into specific subtypes, such as respiratory system diseases, and finally into granular concepts like pneumonia or liver cirrhosis. At the bottom, notice how these concepts link directly to multimodal data, like CT scans and pathology slides. By mapping distinct data samples to this structured hierarchy, the system ensures balanced training across both common and rare conditions. Having organized concepts with the entity tree, Figure 5 outlines the mid-training data construction pipeline, which turns raw information into structured reasoning lessons. In the top section, labeled A, diverse inputs like medical books flow into a curation phase, where knowledge graphs synthesize complex question-answer pairs. Then, Panel B illustrates a quality control step called Experts Group Reject Sampling. Here, multiple models generate reasoning paths that must pass a double check on both the answer and the thinking process. Finally, Panel C details the structured chain of thought construction, which strictly aligns visual captions with logical deductions to prevent hallucinations. Okay, following the data preparation, Figure 7 maps out the post-training pipeline where the model is refined. On the left, the process combines the synthetic data we just discussed with human annotations to build a high-quality dataset for supervised fine-tuning. The bottom row tracks the model's evolution, moving from the mid-trained state through fine-tuning, and finally to reinforcement learning. Crucially, notice the loop at the top. The system actively mines hard or harmful examples using rejection sampling and feeds them back into the process. On the far right, a hybrid reward system, using both strict rules and detailed rubrics, guides this learning to ensure clinical accuracy. Wrapping up, the key takeaway is that MedXIAOHE moves beyond raw scale by using a structured, entity-aware curriculum to handle rare clinical cases. By combining this with verifiable reasoning tools, it offers a robust blueprint for bridging the gap between academic benchmarks and reliable, real-world healthcare applications. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.